Welcome to Unit 7, Sequences and Series, Lesson 1, Arithmetic. Sequences are learning goals today. I understand the properties of an arithmetic sequence and its general term. So for this, we're going to have to define what an arithmetic sequence is in the sequence, and we're going to find the equation of the general term. Find any term given the general term. All right, there's that keyword again, general term, and then determine the number of terms and defined arithmetic sequence. There it is again, we'll define that. And then find any term of a sequence given two terms of an arithmetic sequence. All right, so this unit here is all about patterns. This is why I have this picture right here. It's all about patterns. And this is why this is one of my favorite units in 11 University Math, because it's just strictly patterns, and that's what I believe math is. But here we can actually, we're going out and searching for them, and it's a little more obvious, some of the patterns are a little less obvious, but here we go. So here are some examples of sequences. So it asks you for the next three. So here we got 3, 5, 7, 9. So here we can see that each term we're adding 2, plus 2, plus 2, plus 2. So the next one is 11, 13, and 15. Here, 1/2, 2/3, 3/4, 4/5. So on the top here, we're adding 1. On the bottom here, we are adding 1. So add 1, add 1, add 1. So the next one's going to be 5/6, 6/7, and 7/8. Here, 2, 4, 8, 16, a little more difficult sequence, but we can see here that we just multiply by 2, multiply by 2, multiply by 2, and multiply by 2. So here the next one would be 32, then 64, then 128. There we go. All right, continuing on, let's define a few things here. So what's a sequence, Mr. Wills? A sequence is an ordered list of numbers. So any ordered list of numbers is a sequence. Arithmetic sequence. All right, so this is a sequence, but what is it? An arithmetic sequence is this. A sequence is the same difference. Keyword here, circle it, difference between consecutive terms. So you take any two terms or in a sequence, consecutive terms, and you subtract them, you will always get the same difference. All right, what's a term? A term here is a number variable in a sequence. We'll see variables later on in the more thinking type questions of this unit, but right now focus on numbers. The general term is this: express each term of the sequence as a function of its position. So general term is basically like a function. You plug in a value, you get a value out. That's that. Here is the equation. This is really important here. This is the equation of an arithmetic sequence. T subscript n is equal to a plus n minus 1d. A is, just like last unit, is just the first term of the sequence, also known as t subscript 1. So that would be the first term, so where n is equal to 1. D is the difference between consecutive terms. D is equal to tn minus 1. So you can see that always the bigger term minus the smaller term, not necessarily value-wise, but the second term minus the first term always, just like first differences in grade 9, things like that. N is the number of terms in a sequence, and finally tn is the nth term, or also known, sometimes we can use this as the last term. We also know that d is equal to, we use these ones the most, d is equal to t2 minus t1, or d is equal to t3 minus t2, or we can say d is equal to t4 minus t3, but also always notice that the n value is always larger for the first minus the second one, and always a difference of 1. And then we can just continue that forever and ever and ever. And that's where this guy here comes from. All right. Let's do a few examples. So here's my first example. This one here, I've got the spicy level over here, so this one is very, very mild. Here we go. We can see what a is. The first term is always a, so my a here is 3. My d, I just take two consecutive terms, subtract them. So here, I'll take the first two, so it's going to be 7 minus 3. So here my d is 4. So my general term will be tn is equal to 3 plus n minus 1 times 4. Again, a, d. In the textbook, it actually simplifies it a little bit. So if I distribute this and add like terms, I will accept this answer on a test. But if I distribute and add like terms, I'm going to get equals 3 plus 4n minus 4. Add like terms here, I get tn is equal to 4n minus 1. Again, this is the textbook. This one right here is the one I would accept. Continuing on, all right, let's go more spicy. Given the sequence 5, 10, 15, dot, 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 125, find the number of terms or the n in the sequence. So this would be, I'd say, a little bit more spicy. Here we go. We can still find a really quickly. A is 5. D is 10 minus 5, so D here is 5. So I've got this guy, and I have this guy. All right, so what can I find here? Well, I also know this guy here, this is my Tn. So my Tn is 125. So on my equation, Tn is equal to A plus n minus 1 D. And my Tn is 125 equals A, 5 plus n minus 1 times 5. Distribute this guy in. 125 is equal to 5 plus 5 n minus 5. These two cancel. I'm left with 125 is equal to 5n. Divide both sides by 5, of course. N is equal to 25. Therefore, there are 25 terms in the sequence. All right, let's go to the next one. This one's a little bit more spicy. So given T7 is equal to 14 and T3 is equal to 6, find A and D. So here, again, I'm going to always refer back to my equation. Tn is equal to A plus n minus 1D. And it says here, here's a hint, make two equations, use substitution to solve for A and D. So we're going to have to go back to our grade 10 rules and use substitution. My first one I know is, do this one in red, T7 is equal to 14, so plug it in. 14 is equal to A plus, this guy right here, that is my n. So 7 minus 1 times D. So 14 is equal to A plus 6D. There's my first equation. All right, the other equation is this. T3 is equal to 6. So again, that is my n. So 6 is equal to A plus 3 minus 1D. So 6 is equal to A plus 2D. So what I'm going to do is line these up, and you can see that I've got a common A term in both. So line them up, so I get this. I get 14 is equal to A plus 6D. The other one is 6 is equal to A plus 2D. I can subtract. 14 minus 6 is 8 equals 4D. Divide both sides by 4. D is equal to 2. All right. Once I get this, I can plug this into, I'll plug it into this equation here. So I get my A, I'm just going to do 6 is equal to, A plus 2 times 2. So 6 is equal to A plus 4. Subtract 4 from both sides, I get A is equal to 2 as well. And there we go. I solve for A and solve for D by using substitution. Because my two terms here were the same sign, so I can just subtract. All right, last example, here we go, most spicy. And this is really not much more difficult than the other one, because it's asking for Tn and T15, so again, the first thing I'm going to do is solve for A and D, but again, it gives me this. It gives me T10 is equal to 104, so that means I've got here, so that 10 is really my n value, so I really have 104 is equal to A plus 10 minus 1 D. So 104 is equal to A plus 9D. All right, there's my first equation. My other one, 26. So that would be my n again. So here I'd have 328 is equal to A plus 26 minus 1D. So 328 is equal to a plus 25d. So I've got two equations, equation 1, equation 2. I'm going to use substitution elimination again, so I'm going to have, I'll write the bigger one first, so 328 is equal to a plus 25d. The other one I'm going to write is 104 equals a plus 9d. Again, because they have the common a's, both the same sign, I'm going to subtract. 328 minus 104, this is going to be 224, equals, a's are gone, so by elimination, and here I'm going to get 16d. 224 divided by 16d is, divide both terms by 16. I get d is equal to 14. All right, d is equal to 14. I can substitute in either equation, so I'm going to substitute it into 2. So I get 328 equals a plus 25 times 14 equals a plus 25 times 14. I'll just pull my calculator, do that quickly. It's 350. And so 328 minus 350 is a is equal to negative 22. So I've got my d, I've got my a. So that means my tn term, let's shift down a little bit here. My tn is equal to negative 22 plus n minus 1 times 14. All right, and what else? It wants me to find t15. So here we go. t15 is equal to negative 22 plus 15 minus 1 times 14. Put that in my calculator. t15 is equal to negative 22 plus 14 times 14, and here I get 174. And there we go. So I've got my equation, my general equation there. Here is solved it to find the 15th term. That is the end of lesson 1.